In this tutorial, you're going to learn how to convert a web application into a decentralized application, a dApp. You're going to see the steps that we're going to take, all that you need to know for converting a normal web application into a decentralized application. Maybe you want to do this for a client, for different kinds of purposes. Maybe you're creating a project and you're basing your idea on a web app, which is a perfect idea. Say you want to create a decentralized Instagram, decentralized Twitter. You just create a Twitter, a web application, then you change the server and some different logic, and then you have a decentralized application, which is ideal for ICOs, for creating trustless applications without middlemen, to eliminate all the systems, to you know what I mean. So let's get started and let's create this application. First I have this application. I have this folder called decentralized e-commerce. So let's start this project, and I'm going to show you exactly what I have right now. Let's webpack watch mode production. This is a React.js web application, so I'm using React, Stylus, Webpack, all of these different things. Development. All of these different things for a decentralized application, for a web application, I mean. HTTP server dist. Don't worry about this. This is just starting the web application in development mode. Let's go to localhost 8080, and here's the web application that we have right now. As you can see, this is a store, a decentralized store, e-commerce web application. You have different products here. You can buy them. Right now, the buy buttons don't really do anything because they are just for showing how to do it. And you can add products. This is working perfectly. You can select all this and you have a new product right there. Now if this were a web application, I would have a server where connected to a database where all this information is stored. In a server is, a database is centralized, and a server is also centralized. So what we're going to do is we're going to take that server and that database, and we're gonna remove them from where they are, and we're gonna to use smart contracts for their their functions. Instead of storing all this information on a server, on a database, we're going to store all this information in a blockchain, in the Ethereum blockchain, using smart contracts. So also we are going to take the payments, and we're going to make Ethereum payments, so people will be able to buy products with Ether. That's the idea, because I want to create a store where you can buy products with Ether, with Ethereum, or with tokens. Tokens is just a simple change, but for now let's just stick to Ether. So what do we do? First, I want to store all these products on the database, on the blockchain. For that, I need to create a smart contract. Let's write the steps before even starting. So we need to store all the products on a smart contract with Solidity. Then we need some function to upload those products to the smart contract, and a function to get them. We'll see how we do that, but for now let's write what we need. Then we need to create a function to buy products with Ethereum, with Ether. So whenever someone buys a product with Ether, the user that created that product will receive an email or some kind of notification telling him that someone bought that product with the addresses and so on. I mean, this is an example. This is not a completed web application. Remember that. This is just how you will convert an application, a web app, to a decentralized application. Okay, so now we know what we need to do for creating this decentralized application. You can see the web application, and this buy button will allow us to buy the product. We will process the transaction to the smart contract, and then you will be able to do whatever you want on your server, because it is not completely possible to completely decentralize this kind of things. Things like sending emails, you have to use a server, a centralized server. So you need to sacrifice part of that decentralization on that section. But it's okay until we have complete decentralized solutions. We'll have to use those kind of methods. So yeah, decentralized. What we're going to decentralize is as much as we can using smart contracts. So let's store all the products on a smart contract. Let's create a smart contract called store, and let's start. Okay, let's set up the version. Let's create a contract. Now let's write down the things that we need to store. We need to store products and a function some way. Now, some way to get the products. So first, let's set up a struct called product, which will contain the title, the description, the price, which is a number, the owner. The owner is the owner of the product, and if it's a boolean, and if it's on sale. If it's on sale, and another if it's sold, is sold. Just to make sure that we are certain that it's sold or not. Already sold. Has been sold. Function to upload products. Now, like I said, you can't store images on the Ethereum blockchain. You can convert them to base 64 and different things, but it's not profitable, it's not easy. So ideally you want to store the images in some kind of centralized server on a database, centralized database, because it is the cheapest and the safest and fastest way to store the information. And until now we are only storing the information without the images and heavy data on the blockchain. We want to keep the information as light as possible because the blockchain is limited in size. Upload products. What we are going to do is we're going to receive the title, a product, the description, the price, the owner is the sender. The owner is the sender, so we don't care about that. When we upload a product, the product is on sale and the has been sold will be false. So let's create a new product. My product is a product with this title. Well, first let's make some checks. We have to make sure that the title is not empty, So the way that we check if a string is not empty, we convert that to bytes, and then we check the length is not 0. I think it was that way. I'm not exactly sure if it's correct, but let me check some contracts that I created before, because it's a bit complicated. You see, bytes title 0. We are checking the first element. Okay, it's not 0. The first element is not 0. Okay. You see, it's useful to take a look at your past projects and learn from them. You're always forgetting things, learning new things, so keep them close for learning whenever you need them. We're checking that the description is not empty because we need to have some kind of description of that product, and we're checking that the price is bigger than 0. The price will be a number. Let's write some description. Uploads a product to the list of products of the store. You also need to have some kind of array, maybe a mapping. I've been thinking about different ways we can do this, because an array, yes, we can do that, but it will be harder to find the product. We also need an ID, a unique ID for the product to identify it. Okay, for now let's create an array of products. The problem with this is that we cannot find easily a specific product. We have to look over all the products, and that can be problematic. So instead of that, why not let's try with a mapping, because a mapping allows us to search for a specific product and to get that information without having to loop over a gigantic number of products. It's the best option right now. So we need the ID. We will use the ID and we will return the product. This is a public mapping called products. Okay, my product, let's create the product description. We also have, let me see, the price. Well, first we have the ID. So let's create a variable called last ID, which starts at 0. And the last ID is just a counter of the last ID for adding new products. The last ID basically will increase at the end of when you upload the product, it will increase the last ID. So we use the last ID as the ID of our product. The title, the description, the price. We need the owner, which is the sender. If it's on sale or not. Yes, when you upload the product, it's on sale, and if it hasn't been sold, so that's false. Now that we have a product, let's upload that product to our list of products. In this case, let's set up the ID. Last ID is this product, my product. That's how we update the mapping. Okay, we have this. I think that's it. We can return the ID. Wait, what did I do? How do I close this? Returns a number, returns the ID. So let's return last ID. Well, we have to save the ID somewhere because we are updating the value of that ID, or basically return minus minus last ID. I don't know if this is possible. This only means that we are removing a value from that last ID. Return last ID minus 1. That's the best way for doing this. Okay, my product. Okay, now we are uploading a product. What if we want to get all the products? What do? We have to loop through all the IDs. This is also public. So we will do the same thing as we did before. We will loop over all the IDs to get all the products in the front end. In the back end, and a function to store the products, some way to get those products. Okay. Create a function to buy products with Ether. Okay, let's create a function. Buy product public. To buy a product with Ether, with the address of the user and the products that he owns, which is important for making products owned. This is for making sure, for having a list of the products and the owner of that product. I mean, the has been sold is not really useful right now that I think about it, so let's remove that. Products owned is the address and the ID of the product that that user is owning. Whenever you buy a product, two things happen. First the owner of that product loses the ID, and then the buyer gets the new ID in the mapping. What I mean by this is that we are basically removing the value, the product from, we are moving the ID from one owner to another owner, and the ID of the product. So what do we do first? We first check the ID. We first check that the price of the product is smaller or equal the amount sent. So how do we check that? First we have to get the price of the product. Let's go to the products. Yeah, let's go to the products and the ID. The ID can be 0, can be whatever, and we can get the price of the product by doing this. That is the price of the product. Now we require that price, the price will be set in Ether. That's an important distinction because we will pay in Ether, so the price has to be set in Ether. Let's annotate that the price is set in Ether. Yeah, Ether. So we require that the amount sent message value is bigger or equal the price of the product. If it's less, basically return the transaction. Now if the price is bigger, what we're going to do is we're going to return the difference. So we're going to make MSC value minus, which is bigger, product ID price. Let me check it. uint 256 amount return. The font is this, then message sender, the transfer amount to refund, or basically return the exceeding amount to the owner if you are in that case. Otherwise, do nothing. Yes. Now, first, the owner of that product loses the ID. So we have to go to the thing is the owner. Let's remove the owner from there for now, because we already have the owner here, you see. So let's remove the owner from that struct. As you can see, that's how you actually create a contract. You go through the functions, you go back, you modify things, you change them until they are how you expect them to be. So this is normal to go back and forth between different functions and making different changes. It's also usual that you delete big chunks of code because they are not how you want them to be. So don't be afraid to do that. Don't be afraid to change your code often, to modify the logic with different things. Now we need to update this product's owned function. Product's owned by the sender. I mean, the sender is not the sender. The owner of the product. Who is the owner of the product? That's the problem. Who is the owner? Do we know who is the owner? No. We need to update. So we need the owner. So let's see, we need the owner. I thought that we didn't need that, but we need the owner there. Message sender. Below the price is the owner. So we need the owner. Let's go to the products. ID. Owner. Now we need to. The owner of that product loses the ID. So what we're going to do is we're going to products owned. We will also have to modify this. Products owned by that owner is now 0. Products owned. Yes. Products owned by that owner basically an address with different numbers. Basically this is an address which is something like this with different numbers, like 1, 2, 3, 9, all those different numbers. Now what if I want to delete one? That's the problem. This is a number only. We need an array of numbers. So this is okay. We have an array of numbers, and what we're going to do is the ID, products ID dot owner, and then the number ID. We delete that. So basically, we are going to the products owned of the owner of this product, which is this one. And then we are deleting that ID from the array of products owned, because you have a list of products. You are deleting the specific product that you are selling. Then we are adding that products owned. The sender dot push this ID. We are adding this product ID to the new owner. Remember that the IDs are always unique. We also have to check that the price that the product is on sale. So let's check that. Require products id.onSell. I think that will work because it is a boolean. So I require that is on sale. Okay, we are adding that ID. We also have to update this products id.owner. Products id.owner is equal message sender. You can do whatever you want in your smart contract. You can access different accounts. In this case, products owned, different IDs, because you have access to those variables immediately. So what we are going to do, what we are doing is we are updating the ID. We're moving the one product from a user to another, and we are changing the owner of that product to this new owner, and the product is not on sale equals false. Yeah, when you buy a product, it's not on sale anymore. Upload a product, and that's it. And you can always go to this mapping and check if you are owning a specific product, because you have the ID, and with the ID you can access the array of products, the list of products. Yes, the identifier. Products, last ID. Yes. Okay, now we can buy a product, we can update a product, we can upload a product, I mean, and we can get those products with these mappings and the last ID. So let's copy this code and let's publish that on Ropsten with Remix. We can do that with Truffle, but we are going to use Remix because it's easier for me and it's faster. Let's use this version. And memory, we need the memory keyword. As you can see, this is a simple. As you can see, this is a pretty simple contract. Only 50 lines of code, which is not bad, but it's pretty simple. So it's great for learning. Okay, we have the upload product, the buy product, and let's deploy this with Ropsten store deploy. Let's increase the gas price and submit it. What else? Okay, now we need to go to our application, which is this one. As you can see, this is a React application with stylus. This is stylus. And in this React application, I mean, here we have basically the products. It's in the state. If you're familiar with React.js is just a framework for JavaScript, a very famous framework for creating web applications. I like it for big applications because it allows you to create very powerful websites who are responsive, who interact quite easily. Basically, web applications that are modern and powerful. So we have this state, which is the main object where all the information of the page is stored, and we have all this the products array. In this array, we are storing the products in this format. We have the title, description, and the price. This is what we are seeing here. You can see this is what we are getting. Now first I want to change this euro icon to Ether. because we are now dealing with Ether. So let's go here and let's just write ETH. What else? Now what I need to do is to update all this information. So here's the things that we need to do. We need to get all the products from the smart contract, be able to publish products to the smart contract, and then be able to buy those different products. Also, it is important to not allow to buy your own products. So let's update this. Require that the sender is not the owner of that product, because you should not be able to buy your own products. Even though I made this change. Yeah, let's deploy this contract again. It's a small change, but it is important. Let's increase the gas. Let's close this contract because we don't need it. And what else? Let's go here and let's remove. This is some sample. Well, let's keep that for now. Set initial products. Basically, we have to go to the smart contract, and let me change something. The tab size I don't really like. I want this to be 4 because the tab size should be like this. We have to go to the contract with Web3.js, and we have to get all those products by looping through the array of products and filtering those that are on sale. So we're going to get all the products in the store, and we're going to check only those that are on sale. So how do we do that? We need to first import Web3. I don't know if we need to import Web3 because we're getting it from MetaMask. I'm not really sure if we're getting it from MetaMask, but what I'm sure is that we need to import the smart contract. How do we import the smart contract? That's a great question. What I do is the same thing. I create an ABI.js. Let ABI is this thing. We compile the contract. We have the address of this contract. Let's save it somewhere. We compile the contract by going here and clicking on details, copy the ABI, and then pasting the ABI right there. Now, because we are using React and the new version of JavaScript, the ES6, we have to export this. Export default ABI. Because we are exporting the ABI, we can import the ABI. ab.json. ABI from ABI.js. Okay, we have the ABI. Now we need to create the instance. If you remember, let's go to the project. How would you create the instance of the contract? In the distribution folder, we have the index, which is the thing. Looks like we already have Web3. I'm not really sure if we have Web3 available right now, but let's use that and let's create the instance. So the instance okay, the contract instance is this one. Contract instance is contract instance. Well, I don't really like to store this in the state. let's store in the window object, which is the global object. Contract instance. Add, we need the address of the contract, which is this one. As you can see, it is the same code. We are just updating the ABI and the address of the contract. Is the same way for getting that information. What else? What else? What else? Okay, we have the contract instance. Now we need to set the initial products. So we go to the contract instance. Let's make this async. We can use async, or maybe we can. Yeah, we can use async because we can use promisify all. So there's something called Bluebird, which allows you to convert all the functions, all the callbacks into promises, which allows you to wait for the transaction to complete, which is really great for being able to wait for the transaction. In this case, you want to get all the products and then update the information, not the other way around, because if you are using callbacks, you have to execute something, then inside that you have to make all the things. It's more complex, so let's use only Bluebird. Promisify all. Let me see how is this working. Promisify all. Promisify all. Contract instance. We are promisifying all the contract instance and the Web3 because why not? We are basically taking all the callbacks from the contract, all the functions, and we're making them promises, which allows us to use the async keyword for getting those promises. But before doing that, let's check how this contract looks like. Let's console log that, and let's see. The contract is compiled in the page. Let's open the developer tools. Promisify all is not a function. Yes, because we have promisify all from here. So what we have to do is this. Okay, you can see all events. We have the async method, which is a promisified, as you see, and we can use that for. Oh, you can see we have the ether. We can use that for our purposes. So what we have to do here is get all the products from the smart contract. Whenever I'm working on every application, on a smart contract, or whatever, I like to write what I'm doing, because that allows me to focus, to be in state, and to process everything as I'm doing it. Because if I don't write what I'm doing, I get distracted, I lose my focus, which is really important. It's really important to keep yourself in focus at least for several hours, maybe 2 hours. That's the perfect way. If you can be working for 2 hours, you can achieve a lot of things. So get all the products from the smart contract. To get all the products, we need several things. We need the last ID, which is get the last ID and then loop over all the products, and then only return the products on sale. So first we have to get the last ID. Const last ID is await. We can await, and we have this function last ID async, which is basically contract instance last ID async. We have that function because this is a public function, public variable, and the public variables have that function. So now we have the last ID, and we have to loop over all the products. how do we loop over all the products? Let's make a for loop. Less than last id e plus plus I plus plus. Also, before doing this, let me check the last ID. I want to see console log what I'm getting. Let's reload this. Where is the last ID? Set initial products. Hello? Let me see if this is executing. No. I'm getting the contract instance. Let's update this forcefully. For some reason I'm getting the contract instance which is not there. So let's compile again with Webpack. Okay, we are getting the last ID. So the last ID looks like a big number. So what we are going to do is we're going to take this and we're going to number. I don't know if that will work, but let's try that. Okay, 0. We have the last ID. Now what we are going to do is we're going to create a let products, which is an empty array, and we are going to set products equals to products. Now we have to take products dot push. Okay, first we have to loop over all the products and we have to push only those products where. Let's add some products first from here. Let's upload a product called the title. We need the title. This is the title. This is the description. We also need the price, which is maybe 20. Upload product. Let's increase the gas price. We have to wait until this is processing. So I want to make sure that we are getting all the values, all the elements, all these elements in order, because I don't really know if we are getting this as an array or as an object. It's not quite clear for me right now. So I want to upload a product and see how it works. Okay, the transaction is there. Let me check the last ID, which is 1. And if I go to the 0, I get all this information. Great. Now let's log the products. Console log. First product is await contract instance dot. It is called products. The products async. Remember, this is a public variable, so we have a get method for this variable, and we have the async keyword from the promisify method, which allows us to use promises, which allows us to use the await function and wait until this is completed, which is easier because it's more manageable instead of using callbacks. So let's go back and reload the page. Invalid number of arguments to the selected function. Yes, we need to select the number of the product that we want to get. In this case, it is I. Wait, you see we're getting the product. Yes, we're getting an error there, but don't worry about that for now. We have the product, first product, which is, as I expected, it is an array with all the elements organized, but I want to make sure that it is that way. So now I want to take this take this fifth element and only push the elements, only show the products which are on sale, which is, this is true. If okay, first let's get the product. Let my product is this one. My product. If my product 5 is, if it's false, if it's not on sale, if this product is not on sale, don't add it to the list. So basically we say continue. If you remember, is some basic JavaScript functionality which means that we are skipping this element and we're going to the next immediately. This element from this loop, we're skipping this element, we're going to the next without continuing without executing this code below. Now otherwise we add this element to the list of products. So we go to the products array, we say push, and we push the title, which is, as you can see, it is the first element, my product 1. We also push the description, which is my product 2. We also need the price, which is this element 3. Price product. We need to convert that to number, so let's do this to number. I don't really like this to number because it is a string. After all, it can be a really big number, so it's better to convert this to string, because in a string you preserve all the digits as they are. If you convert this to a number, JavaScript will approximate that value to a different number, so you will lose precision in the process. You will lose digits. We have the price, we have the owner. In my web app I didn't have any owner kind of thing, but it's great to have it for later. Product, the owner is 4. We don't have to say that it is on sale because we already know it, and we need the ID, so let's use the ID for identifying the product. 0, which is to number. In this case we can use a number because the ID is always a fixed small number. Yes, we have the products, and we are going to take this and do products. We're taking this array and we are updating the state of the product. So now we should be able to see this product. This is the title, this is the description on our website. Let's reload the page. We see that we have an error somewhere. Let's go to Webpack and the price. Yes, I missed a comma, which is here. Reload the page, and now you can see this is the title, this is the description, 20 ether. You can see we have all this in our web applications. Congratulations, this is a very big step. If you made it through this, if you are understanding what is going on, congratulations. Otherwise, feel free to rewind the video to try it on your own. My best recommendation is that as you watch this video, you have your own website, your own web application, and you convert it to a decentralized version. If you have, let's say, a Twitter-like website, you try to convert it to a decentralized version with a smart contract, just like I'm doing right now, just for practicing, because this is excellent for practicing, for learning Solidity, for creating decentralized applications. After all, this is what matters, the ability to be able to create decentralized applications and smart contracts. Now we need to add a product and to buy the product. To add the product, I have a function. Let me find that. To add a product, which is publish function. This publish product is the function that I'm using to upload a product to the list of products. So yes, this is the product object, but we don't have the owner. We need the owner, so let's console log. We need the owner and the ID. So the last ID will be saved here. Last ID is, let's say 0. So we go in here, we're going to the state, and we set the last ID to whatever value. This is last ID. We need the last ID for uploading new products. It is important. So we have this over here in the state, in the React.js state. Okay, the ID will be this.state.last ID. Great. And the owner will be web3 owner. For now, let's comment that and let's check web3. web3.eth.accounts. Basically the first account. web3.eth.accounts 0. This is the owner, the user that is connected on MetaMask. You see, I'm getting this from MetaMask. I'm connected here, and I'm getting this address here. We can use this information on our own application. So we are publishing a product with all this information. Do we need anything else? Let me see. Well, in reality, we don't even need the owner because we already have it. Do we need the ID? No, we don't even need the ID for publishing this new product. So let's forget the ID. We don't even need that information. What we are going to do is we're going to async this for being able to await, and we basically await contract instance dot upload product. We're going to upload this product async, and we are going to upload the title, which is this title. Well, let's make product title. We're going to update the description and the price. Description and product.price. Remember, it's always important to test your applications, your web applications, your smart contract, because you may have issues, especially if you're dealing with money with Ether. Of course, if you're learning, you don't even need to test them because you are just using this for learning. But if it's a real application, you have to test them to make sure they are working properly. So what we are doing here is we have all this information about the new product. Basically, when I click here, I write all this information, and that information goes to this function, publish product. I have the title, the description, the price here. So I'm uploading that information to the smart contract with this, with the upload product function. You see, we're taking the contract instance and we're executing the upload product function. If you are lost or if you're confused, go back to the video and try again until you really understand what is going on, because it's complicated. We're uploading the product and we can remove this. Well, because what I was doing before this is I was just adding the product to the list of products, but now I'm uploading the product and updating the view. Basically, I'm showing these new products. The problem is that we have to wait until the transaction is processed, so Let's just keep this as it is. Okay, this is perfect. Let's try to upload a product. By the way, there are no errors. Let's try with another one. We should be able to get an error, a transaction from MetaMask. The description of product 1 Ether, in this case publish product. You see, we are getting a transaction to publish that product on the blockchain. So we have to wait until the transaction is processed. What else do we need? We need to be able to buy those different products. That only means that we are just changing the what do we need to buy products. First of all, let's go to the function. We need the ID of the product to buy. That's it. Let's create a function to buy that product, because I don't really have any function to buy product. All this information you will be able to use this product information to create a page with your own products and things like that. This is ideal for digital things because you can directly see all that information. You can see the product that I just published is not yet there. So let's wait. Buy product. First of all, when does this execute? When I click the buy now button, I should be able to get, well, first of all, I need the ID. The only thing that I need is the ID. So let's go here, the ID. And the ID is set in this state show products. So I already have this ID. ID is this. Yeah, let's set up like this. I don't really want to set up the ID like this. The best way is to create a hidden input to save the ID somewhere. Input type hidden, and the value will be the ID. This props.id. Basically, what I'm doing here is I'm taking the ID from that product and I'm saving that information on the website, because before that I wasn't really using that information anywhere. I was just updating the state of the product but without showing it on the web page. Let me reload this. Okay, as you can see, we have the new product that we just added, and we don't even have a server. We have all this information on the blockchain, which is permanent, and that's cool. As you can see, we have the ID, but the value is empty for some reason. That's weird. This props ID. Show products, we're getting that information from show products, which has been updated here. Or not? No. Update products. Okay. The ID is here. Product.id. Now we will see the ID of the product. Wait, what is going on? Okay, we have the ID with the value 1, and in this case 0. You can see this is the ID, which is 0 for this one, and the ID is 1 in this specific product. Okay, now what do we do with that? Basically, when you click on buy now, we execute a function on click. We execute a function which is this props.buy product with the ID. This function will be executed right here. By product we are going to execute this. Okay, when this is executed, we're going to execute this dot by product with the ID, of course. If you're a little bit confused with React, with JavaScript, don't worry, this is just some information about the framework. What I'm doing here is just when you click on buy, we are executing this function with the ID of the product. And now that we have the ID, we can execute this function, which is await contract instance dot by product async, and we set the ID here. We also need, how do I send? Okay, to send something, I think I have to do something like this. I'm not really sure. So let's try that. Let's try to buy a product like this. Let's go buy now. There are some errors. ID is not defined. Across origin error was thrown. Doesn't have access to the actual error. ID is not defined. Okay, somewhere the ID is not defined. The ID is this props ID. Okay, we don't even need to show this information. We can just store this over here. Okay, that's correct. No. Okay, we're buying. You can see I'm getting an error because I'm the owner of these products. So let's change the account to this one. Let's get some ether, test ether. And I should be able to buy these products. It's taking its time. We have to wait until we get the balance, the ether from the faucet, which is really cool. Okay, we have the transactions for getting ether. Let me see. Okay, looks like we already have the ether, so we can go back to our application and buy this product. Whoa, for some reason we're getting an error, even though this product is not mine. It's because before this I thought that we were getting this error because I'm the owner. Well, this is a requirement, but now I think I'm getting this error because the price, I'm not sending any price. When I click on buy now, I'm not sending any ether. You can see the amount is 0. I have to send 1 ether. How do I do that? Well, as simple as going here. I don't really know if I can, so let's try with a value web3 to weigh 1. Is that correct? Web3 to weigh 1. Okay, I'm getting 1 ether. So value is 1 ether. Let me see if this is working or not. Buy now. Okay, we are sending 1 ether, but for some reason I keep getting this error. I keep getting this error. Let's try to send a bit more. 1.1. In fact, this is not even the correct amount. By product ID, we have to send also the price of the product, the ID and the price. This props price. Going here, price. I mean, price is in here and the price is from here. Price, ID, price. We have the price here. Let's take the price. Wait. So let's see if this is working. Right now, when I click on buy, I'm sending 20 Ether. There is not enough balance, but right now I have enough balance. I'm not the owner of that product, but still I cannot buy it. What if I go to Remix and if I try to buy it? Oh wait, let me copy this address first. Let's go to Remix and try to buy a product. For some reason I am getting this error, which is not cool. I mean, the values has to be bigger or equal the product's id.price. Okay, let's go back to here, load this and try to buy the zero product. Send transaction. What? Now I'm not getting any kind of error. First of all, I need to send. I have the ID. Well, first of all, am I sending the ID by product as sync? Let's console log the ID because I'm not really sure. When I click on buy product, what I'm really trying to buy. 0, the ID is 0, which is correct. Insufficient balance for the transaction. The ID is 1, but for some reason that is failing. Okay, let's try to buy this one with 1 Ether. So if I try to buy the product 0, I mean the product 1 because it costs 1 Ether, I try to buy that. Let's try it. Hello, send transaction. The transaction will likely fail. I don't know why will that fail, but let's try again. In any case, I think this is why it is failing. This is only a matter of time of fixing this. So I will leave you the code, the working code, in the description, and you basically will see how this works. But this is the basic application. We have the application completed. Basically, we converted the web application, the front end, to a decentralized web application with Web3 smart contracts and some changes in the logic of the front end, because we had to change the logic of the front end. We had to modify the code. Let me upload this to GitHub. Git at all, git commit /m decentralized the web app, git push. The GitHub repository is decentralized e-commerce. You will see there the latest code with the working version, because I will fix this until it is working. But right now, as you can see, the code is we can add products, we can get the products from the smart contract, but the buy button, for some reason, it is failing. The thing is, this is working, but there's some small thing in the smart contract that is failing, which is something that I'm not really getting. But that's okay. Don't worry about it. I will fix it. And that's how you do it. You learn in this video, you have learned how to take a web app, a web application, a website, and to make it decentralized with a smart contract. Remember, there are things that are not that really easy to decentralize. Things like images, videos, processing things like sending emails is not really possible. On a blockchain, you have to do them on a server, on a centralized server. You have to store images, you have to store videos on a centralized server. Maybe you can use IPFS, but IPFS right now is not really that decentralized. You have to make sure that it is online, and it's not that really decentralized for now. So you can use that, but keep in mind that it's not the best solution. And that's how you do it. You try to take all the aspects, all the information, all the things, and you try to make them decentralized. Of course, in the ideal world, you will be able to store the website in a decentralized server, the images in a decentralized server, the videos in a decentralized server, on a blockchain, whatever. But for now, we have to decentralize as much as possible and keep the other things on a server, on a centralized database, wherever it is, because there is no other place. So that's it for this video, and thank you for watching.